This lesson is on the law of cosines. And the nice thing about the law of cosines is that it works for acute, right, and obtuse triangles. So you're not stuck with just having to have a right triangle. This will work on different styles of triangles. We're going to use the law of cosines when they give us three sides or we know three sides of the triangle, and also when we know two sides and an angle between those sides. And you recognize that situation because all of the letters naming the sides and angle will be different. So those are the two times that you're going to try to look for to use the law of cosines. Okay, so here's the formula, and it looks like I have three formulas here, but I mean, if you'll notice, it's the same pattern every time, just with different sides and angles. And so again, a reminder, when I'm naming a triangle now, I'm going to use capital letters for the vertices and lowercase letters for the sides across from those vertices. So big A is across from little a, little b is across from big B, and so on. So if you look at the formula, this is one that will be given to you on your formula sheet for the final exam, but it's so easy. I mean, you can pick it up after you use it for a while. So you start out, if you are given all three sides, then you want to start with the side that's across from the angle you're trying to find. So if they give you sides A, B, and C, and you want to find, say, angle B, then you're going to start with side B. If you are missing a side and want to find it, then you want to also start with that side. So if you look at the pattern, we have something that looks sort of like Pythagorean theorem, a squared equals b squared plus c squared. And then minus the BC here, it will always be the two letters that are on this side of the equals mark. And then the cosine of the angle across from the side you started with. Okay, so write this formula down. You can write down all three, or you can write down one and just realize the pattern. But you're going to have to be able to use it. So, moving on to example 1, we have solve the triangle with sides 1.5, 2.3, and 1.9. So this is the first situation. This is where we have all three sides, and you just have to decide, okay, what angle do I want to find first? And I'll just go in alphabetical order. I'll find A first. So since I want to find angle A, I start with side A, and I have that side squared equals the other two squared and added together. Then I'm going to subtract those two sides. And then the cosine of angle A, and again, angle A is what I'm trying to find, so I don't know what that is. And then I just start plugging in my calculator. So 1.5 squared is 2.25. I'm going to go ahead and add these two together and get 8.9, and then put my subtract and figure out what this multiplied together is. And that will be 8.74 times, again, the cosine of A. Now, before I go on, the absolute biggest mistake people make is they take this number and subtract this number. You cannot do that because this 8.74 is attached to the cosine of A by multiplication. It's like trying to say 5 minus 3x. You can't work with that 5 and the 3 because they both don't have the cosine of A. Your only option is to subtract the 8.9 first, and you get a negative over here, so negative 6.65 equals what's left. And then, again, this is multiplication, so you want to divide by that negative 8.74. And that's going to equal the cosine of A. And I'm not even going to worry about it too much. I'm not going to type that in and worry about simplifying. I'm going to write it as positive because I have two negatives. And you have to remember, if you're missing an angle, that's when you use the inverse. So my angle A is going to be the cosine inverse of that fraction. Or if you typed it in, the decimal that you got. But I just saved myself the work of typing. Just leave it like it is. The calculator will take it. Do the cosine inverse in your calculator and make sure you're in degree mode. We have 40.46 degrees as our answer here. So that found me angle A. Now, one thing about this is this says solve. Solve means find everything that's missing. So I also need to find angle B and angle C. The nice thing is, after I find one more, I can just do add my angles up to 180 and find that third one. Okay, now I got a little more room. I'm going to go ahead and go with B because, I mean, why not go in alphabetical order? So I'm going to start with side B. So 2.3 squared is going to equal 1.5 squared plus 1.9 squared. Then subtract 2 times the two sides that are over here, so 1.5, 1.9 times the cosine of angle B because I started with side B. And again, do this the same kind of way that we did the last one. First, I'm squaring the 2.3, get 5.29. I can go ahead and add these two together and get 5.86. Put my subtract, multiply 2 times 1.5 times 1.9. I get 5.7, and I'm multiplying that by the cosine of B. Again, I have to subtract this part first, so minus the 5.86, and I get negative 0.57. And then I'm going to divide, and I have negative 0.57 divided by negative 5.7 equals the cosine of B. And again, for angle B, that will be the cosine inverse of that fraction. I have, again, got two negatives, so I'm going to make that positive. Type that in my calculator. And make sure, again, I'm in degree mode, so 84.26 degrees. Now, I have angle A and angle B. I don't have to do this again for C, although I could. Because I do have a triangle, I can use the laws of triangles and the fact that these angles add up to 180. So C is going to be 180 minus the other two, so minus 40.46 and 84.26. So C will be 55.28. And so now I have solved the triangle because I have found all of the missing parts. For this example, I'm going to use the other case. I have two sides and an angle between those two sides. And again, I can recognize this because all three of the letters are different. And that's how I know to use the law of cosines. So, I'm again solving the triangle, which means I've got to find all the missing parts. So if you look at what I'm missing side B, angle A, and angle C. So I have three things to find here. I am going to start out by finding side B. Because I have angle B, this shouldn't be too hard. Since I want to find side B, I start my formula with B. So B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B, which we know this time. So this is a little bit different than that last problem. I actually know this angle. Also, what's nice is everything to the right here is numbers. You can type that in your calculator exactly the way you see it. It's not as complicated as that first problem. Just type everything in. You get 191.78, and then you just take the square root of that. So side B is 13.85. Now, I am missing two angles, so I'm going to have to do the law of cosines again. And so you just decide which one you want to find, and I'll just find A. So I'm going to start my formula with side A. So I'm going to do the 10 squared again equals the B we just found, 13.85 squared, plus the C, which is 8 squared. And I don't know why I put parentheses there, sorry, don't stress over that. 2 times 13.85 times 8, using those two sides, and then the cosine of angle A, and again that one I don't know. So this is like that first example. I've got to do my combinations first and do a little bit more work. So 10 squared is 100. This 13.85 squared and 8 squared add together to give me 255.82. And then 2 times 13.85 times 8 is 221.6. And so I want to then subtract the 255. And that's going to give me a negative 155.82. And that's going to equal the negative 221.6 times the cosine of A. Need a little more room. Divide. So I have a positive 155.82 over 221.6. And again, it's positive because I had a negative divided by a negative, so it's got to be positive. That equals my cosine of A, and again, I'm doing the inverse to get the angle. So A is going to equal cosine inverse of 155.82 over 221.6. And when I type that in, I get 45.3. So now I don't have to do the law of cosines to get angle C because I already have two angles. I can just subtract from 180. So 180 minus angle B, which was 100, and angle A, which was 45.3, gives me 34.7 for angle C. And I found all the missing parts because I found side B, angle A, and angle C. Now, with these problems, sometimes they'll just ask you to find one thing, but if they do say solve the triangle, they want you to find and make sure you know all of the sides and all of the angles. And that concludes this lesson.